The second learning outcome focuses on selecting, installing, and supporting a hard drive. In this part of the learning outcome, we focus on selecting a hard drive. When selecting a hard drive, it's important to make sure that the motherboard and the drive are supporting the same standard. It's also important to be aware of the features offered by the drive. In cases where your SATA drive has two power connectors ports, remember not to install two power cords to the same drive at the same time, as this would damage your hard drive. The first thing to do before carrying on with installation of a new drive is to back up the most important data. It is important to know your starting point before you begin installing a hard drive. It is important to know which components or devices are working before installing a new one. This will later on help to isolate the problem if the new device or component doesn't work. Another way to look at this point is you need to know how was your system configured and what was working before you make new installations. Next step is to read the documentation and prepare your work area. Before you start replacing, it is important to first read all the documentation for the drive as well as the part in your motherboard manual that covers hard drive installation. In this step, you can now start installing the drive. In the prescribed textbook, a suggested practical procedure guides throughout the installation. First, shut down the computer, unplug it, and press the power button to drain residual power. Next, for 2.5-inch or 3.5-inch drives, decide which bay will hold the drive by examining the locations of the drive bays and the length of the data cables and power cords. Next, for a stationary bay, slide the drive in the bay and then use a screwdriver to secure one side of the drive with 1 or 2 short screws. Next, when using screws to secure the drive, carefully turn the case over without disturbing the drive and put 1 or 2 screws on the other side of the drive. Next, check the motherboard documentation to find out which SATA connectors on the motherboard to use first. Next, connect a 15-pin SATA power connector or 4-pin Molex power connector from the power supply to the drive. Next, check all your connections and power up the system. Lastly, to verify that the drive was recognized correctly, enter BIOS UEFI setup and look for the drive. Different desktop cases use different procedures to install a drive in a removable bay. But one thing that is common in all the procedures is that you will have to remove the drive case off the computer case. In addition, unscrew or unplug the clips that are holding the drive. In cases where your drive is smaller than the drive bay it is supposed to be mounted on, you will have to use a universal bay kit to fit your new drive. It is important to first read the motherboard manual to find out the types of M.2 cards the board supports. Here we look at suggested steps you might take to install an M.2 SSD card. For example, measuring the length of the card and decide which screw hole for the M.2 slot the card requires. Next, slide the card straight into the slot. Next, install the one screw in the standoff to secure the card to the motherboard. Next, start the system, going into BIOS UEFI setup and making sure the M.2 card is recognized by the system. Before installing an internal hard drive for your laptop, it's important to first check the laptop manufacturer's documentation to learn about the specific capacities, form factors, and connectors that will fit your laptop. You must be aware of voiding a warranty if you do not follow the laptop manufacturer's directions. If the old drive has crashed, make sure you have recovery media before you start. Remember, you will need the recovery media to install Windows and the drivers. If you are upgrading from low capacity to high capacity, consider how you will transfer data from the old drive to the new one. Redundant array of independent or inexpensive disk, that is known as RAID, is an array that describes two or more drives working as a unit. The two reasons why you might consider using RAID include when you want to improve performance by writing data to two or more hard drives so that a single drive is not excessively used. The second reason is to improve fault tolerance. The four most commonly used types of RAID include spanning, RAID 0, RAID 1, RAID 5, and RAID 10. It is very important to describe each level. For example, in spanning, data is written to the first drive, and when it is full, the data continues to be written to the second. In RAID 0, data is written evenly across both disks so that neither receives all the activity, and that improves performance. In RAID 1, data is mirrored or duplicated on one drive and is used for fault tolerance. RAID 5 stripes data and parity information across 3 or more drives and uses parity checking. RAID 10 is a combination of RAID 1 and RAID 0. You would use RAID-enabled motherboard to set up hardware RAID or RAID controller card. It is suggested that all hard drives in an array should be identical. That is to say, they must be identical in brand, size, speed, and other features. Implementing RAID levels describe different methods of providing data redundancy or enhancing the speed of data throughput to and from groups of hard drives. They do not say how to implement these methods. Literally, thousands of methods can be used to set up RAID. The method you use depends largely on the level of RAID you desire, the operating system you use, and the thickness of your wallet. The obvious starting place for RAID is to connect at least 2 hard drives in some fashion to create a RAID array. Specialized RAID controller cards support RAID arrays of up to 15 drives, plenty to support even the most complex RAID needs. Once you have a number of hard drives, the next question is whether to use hardware or software to control the array. All RAID implementations break down into either hardware or software methods. Software is often used when price takes priority over performance. Hardware is used when you need speed along with data redundancy. Software RAID doesn't require special controllers. You can use the regular ATA controllers or SATA controllers to make a software RAID array. But you need smart software. The most common software implementation of RAID is the built-in RAID software that comes with Windows. The disk management program in Windows Server versions can configure drives for RAID 0, RAID 1, or RAID 5, and it works with PATA or SATA. Disk management in Windows Vista can only do RAID 0, while Windows 7, 8, and 8.1 and 10 disk management can do RAID 0 and RAID 1. Windows Disk Management is not the only software RAID game in town. A number of third-party software programs work with Windows or other operating systems. Software RAID means the operating system is in charge of all RAID functions. It works for small RAID solutions but tends to overwork your operating system easily, creating slowdowns. When you really need to keep going, when you need RAID that doesn't even let the users know a problem has occurred, hardware RAID is the answer. Hardware RAID centers on an intelligent controller, either a PATA or a SATA controller that handles all of the RAID functions. Unlike regular PATA or SATA controllers, these controllers have chips with their own processor and memory. This allows the card instead of the operating system to handle all of the work of implementing RAID. Most RAID setups in the real world are hardware-based. Almost all of the many hardware RAID solutions provide hot swapping, the ability to replace a bad drive without disturbing the operating system. Hot swapping is common in hardware RAID. Hardware-based RAID is invisible to the operating system and is configured in several ways, depending on the specific chips involved. Most RAID systems have a special configuration utility in FlashROM that you access after CMOS, but before the operating system loads. Every device in your PC needs BIOS support, whether it's traditional BIOS or UEFI BIOS. Hard drive controllers are no exception. Motherboards provide support for the ATA hard drive controllers via the system BIOS, but they require configuration in CMOS for the specific hard drives attached. In the old days, you had to fire up CMOS and manually enter hard drive information whenever you installed a new drive. Today, this process is automated. As a first step in configuring controllers, make sure they are enabled. Most controllers remain active, ready to automatically detect new drives, but you can disable them. Scan through your CMOS settings to locate the controller on-off options. This is also the time to check whether your onboard RAID controllers work in both RAID and non-RAID settings. If the controllers are enabled and the drive is properly connected, the drive should appear in CMOS through a process called auto-detection. Auto-detection is a powerful and handy feature that takes almost all of the work out of configuring hard drives. PATA drives had priority according to the master-slave settings and such. You connected the drives and checked the auto-detect to see if you got it right and plugged everything correctly. SATA changed auto-detection a little. Motherboards with SATA connectors use numbering system, and every motherboard uses its own numbering system. One common numbering method uses the term channel for each controller. The first boot device is channel 1, the second is channel 2, and so on. So instead of names of drives, you see numbers. If you want your computer to run, it's going to need an operating system to boot. You assign boot order priority to drives and devices in CMOS. In the picture, you see a typical boot order screen with a first, second, and a third boot option. Network attached storage, known as NAS device, is a device that attaches to a network for the sole purpose of storing and sharing files. In this picture, we can see a storage enclosure that can be connected to the network. The hard drives inside the enclosure might use a SATA connection.